heard about even function or odd function, but you never really see a question ask you that in the exam or in the test last year. So just let you know, I can't give you this question yet because it's talking about anti-differentiation, but it combined with even function. It's last year's exam, 2017 VC exam, multiple choice question 17. If you can write that down on your paper and we can go back to this question, is connect with even function. When you go through your notes to do revision, this is a good question to think about even function. So I can roughly tell you what that question is talking about. That question says, give you a graph. Okay, the graph looks like this. Some shape similar to this. And then it doesn't tell you what's the equation is that function, but it says that it says that f negative x equals to fx. That's the only information you have. Okay, that give you the information. Say f negative x equals to fx. So what you know from the thing given to you, that's an even function. Okay, that's an even function. So what's the important thing about even function? Okay, this formula doesn't really help. What you need to think about is symmetrical about the y-axis. Okay, for even function, it's symmetrical about the y-axis. Therefore, but it doesn't tell you this point and this point. It says b and c, and that's 0. So what do you think b plus c will equals to? What do you think b plus c will equals to? 0. Okay, that will equals to 0. Because it's symmetrical, if b is negative 3, c is 3, which means you add them, that will give you 0. So in that question, we use that fact. Okay, there are 5 options, and the correct answer really looks weird because it says, integral from a point to b plus c. You think, that's definitely wrong. Most of the students directly cross out that answer. Okay, but it's an even function. The two x-intercept must be symmetrical. You add them, that must be 0. I can't talk about more because it's anti-differentiation later, but just let you know now, even function is tested in last year's exam and is quite important, and most of the students can't get that question because they directly cross out the correct answer. Okay, so that's for even function. And for odd function, one question. Do you think even function must pass through 0, 0? Do you think the function must pass through 0, 0? Let's say, can this function pass 0, 2? Yes or no? Always pass through 0, 0? No. Okay, it can look like this. Okay, it can look like this. So it not necessarily pass through 0, 0. It can just needs to be symmetrical about the y-axis. Okay, odd function. Odd function is symmetrical about the origin. Okay, symmetrical about the origin. Do you think odd function must pass through 0, 0 or not? Yes. Okay, so odd function must pass through origin. But this one is not necessary. Okay, not necessary pass through the origin. So for even function, not necessary pass through the origin, but for odd function, must pass through the origin because it's symmetrical about the origin. So that's all I want to talk about for even function and odd function. If asked you to prove whether a function is even function, odd function, or neither, like just go for one example. Let's say for question 3, for that example, whether hx is an even function or odd function, first of all, think about the power. Those two power is even power. It can only be even function or neither. It's not going to be an odd function. So how you can do the proof? I find students like very weak in proving things. Okay, so how you can start with your proving? What you all need to prove is this function. If you can say, that's true, f negative x equals to fx. If that's true, then this function must be an even function. But most of the students will start from that line. Okay, they will write f negative x equals to fx. You can't start with your conclusion. This is a conclusion. You won't say, my conclusion is that, it must be an even function. You need to prove that. So So what you need to start with is you want to see whether they are equal or not. You will start with h negative x equals to what? So h negative x is negative x to the power of 6 minus 3 negative x to the power of 2 and then plus 2. Then that's x to the power of 6 minus 3x to the power of 2 and then plus 2. Okay, so that's h negative x equals to that. And then you say, therefore, h negative x equals to hx. Okay, you can see that the same. You have hx, you have h negative x, and then you can say, oh, they are the same thing. You can't just start with h negative x and hx and try to go both sides at the same time. You can't do that way. So I'll show you the wrong way. Okay, negative x, if you start like that, and then left hand side you say that. And then right hand side, don't copy that, okay, that's wrong. And right hand side you say this, and then you go, oh, x6 minus that plus that equals to that, and so is an even function. That's completely wrong. Okay, from the first line you already make a wrong, maybe wrong assumption. How about if it's not equal in the end? Like, you can't say in this way. So this is a wrong, like, wrong way to prove. So you should start them separately. Left hand side, right hand side, then they are equal. That's the correct way to prove them. Okay, so I'm not going to talk about more about it. The only question I see in VCE paper is 2017 last year paper question 7, multiple choice question 17, talking about even functions. Okay, so whether better we aware of it and prepare for it. Okay, then we just have textbook. I never really seen VC exam ask you to sketch that, but maybe in the SEC we may ask you to do some of the easy ones. So what you need to think about, so fx is a function, gx is a function, I want to add them. So when you're adding them, for the same x equals to 3, you add those two y values, okay, you add those two y values. So if you say minus f minus g, it will be the same as fx plus the negative of gx. Okay, you put a negative sign first and then add them. We don't really think about minus, we think adding the negative, So when you add them, there are a couple of points you need to be aware of. First of all is the point of intersection. I'll just sketch a graph for you. Let's say here. And here. Okay, let's have a look. Just this is fx, this is gx, that's the x-axis, that's the y-axis. You can find the general shape by make sure you label a couple of points. Okay, so what are the points you need to be aware of? First of all, if fa equals to ga and that equals to n, it's talking about this point. Okay, that's the a value and that's the n value. They are intersects here, there are intersections there. So when you add them, it will be twice as high as that one. Okay, so you can make sure that's twice of that height. So which means your new point will be somewhere here. Okay, somewhere there. That's the first point you need to be aware of. Another point, the second point is, if you have fa equals to n but ga equals to 0, we are talking about this point. Okay, one graph got a y value of 0, which means the new function will make the point stay here. Okay, the point will stay here. That's another point you need to label. Vice versa, if you have fa equals to 0, ga is n, is the same thing. So this is one point needs to label. This is one point needs to label. And there's another thing is, if fa equals to n, ga equals to minus n, if they are one at the top, one at the bottom, roughly you think they have the same distance. We are talking about, for example, this point. Okay, for example, this point. Okay, one positive, one negative. You will have the adding them, you will have a 0 point. Okay, they will stay at 0 because you have one positive, one negative, you add them, they will have x-axis intersection. So that's one point you need to label. That's the 3 points you need to think about, be aware of. The next thing is make sure where are your graphs. So have a look at here. If your graph is all above x-axis, okay, it's all positive, which means the adding graph must be above x-axis as well and above both graphs. Okay, so your new graph must be beyond both graphs. For example, here, up to this line, the black line, all the graph must be above the x-axis and above both graphs. So your graph must go beyond those two blue graphs. If you have one positive and one negative, the graph must be in between those two graphs. Okay, in between those two graphs. You're adding something and you subtract something down, it must be in between. So your graph will be in between. If you have two negative graphs, okay, all below the x-axis, it will be further down than those two graphs and must be below the y-axis. So that's make sure where your graph will about to be. Okay, that's the key idea how we can sketch those graphs. Okay, how we can sketch the sum and subtraction graphs. I don't think I have enough time to talk about the multiplication, but we don't really do multiplication. The multiplication is if you have 0, you times them, the other one must be 0 as well. So that's only thing for multiplication. Okay, very similar to addition and subtraction. We pay more attention on addition and subtraction of the graph. So you can have a look. Those example ones, just adding them and substitute values in, that really easy example. Finish those example by yourself because they are just simple adding functions. Have a look at example 2. I want you to sketch fx squared, gx equals to root x. But you're not going to sketch root x. Why? You are doing f minus g. So you will do minus gx. So minus gx will be negative root x. Okay, negative root x. So sketch those two graphs first. Sketch x squared and sketch negative root x. Let's make a domain. I want the domain 0 from infinity. Just sketch half of it. Just sketch half of it. Hopefully you still remember square root function. Okay, square root function. No, like added this direction, this direction, this direction, or this direction. That's the square root function. Okay, make sure which direction is your graph. Negative root x will be this one. This is root x. This is negative root x. This is root negative x, and that's negative root negative x. Okay, the full direction. Okay, so square function like that, and the green one is the square root function. If you sub 4 in, negative root x will be negative 2, so you have intersection about there. So according to what we think about, those two graphs all got 0, 0. So you must have the new function still at 0, 0. Right? That must be 1 point. Okay? Why I restrict this domain? Because square root x got like a domain itself must be 0 to infinity. Why I restrict it? Even though I don't restrict it, you can only have half of the graph. Okay, you can only have this part of the graph. Is implied domain. Okay, square root x is the implied domain. So you must have can only have 0 to infinity. When you add two functions, like when you add two functions, fx and gx, what's the domain for the new function? The domain can only be the intersection. Okay, the domain can only be the intersection. Because let's say for this blue graph, you can have the other half, but you have nothing to add from negative infinity to 0. Okay, when you can adding them, it's only from 0 to infinity. So it will be the intersection of two graphs. It can't be the full domain. You must find the smallest domain from both graphs. Okay, so that's why I restricted from 0 to infinity. Okay, it's not because of I want to make it. That's because square root x got implied domain from 0 to infinity. And for adding them, can only be from 0 to infinity. Okay, so back to what we talked about. You have 0, 0. So 0, 0 here must be one special point. You must label it. Okay, you must label it. The other one, okay, the other one. Let's think about the 1, negative 1 place and this 1, 1 place. Okay, you sub that 1, 1 in square 1, 1, 1, x squared is 1. And you put 1 in square root x, negative square root x is negative 1. Those two places, they have the same distance. Okay, they have the same distance. You know that. So therefore, you must have another 0, 0 here. Okay, you must have another 0, 0 here. Okay, as I said, okay, it's hard to explain here, but this is positive. This is negative. Okay, this is positive. Blue is positive. Green is negative. Where the graph will be? Where's the new graph will be? In between those two graphs, right? As I said, one positive, one negative must be in between those two graphs. But another thing is, I have two x-intercept, which means the graph must turn somewhere. Okay, how you can have two x-intercept? It must be that shape, like that, or like that. You can't just go all beyond here. So it must turn somewhere. And also, let's think about for x equals to 3. That point is very high, it's 9 already. And this negative is very little, okay, very little negative. This is only like square root 3 is 1.7 something. So when you add them, 9 plus negative 1.7 is still positive. Okay, the further the graph to be more positive, like the graph will be more positive. Even though you add the negative, it still will be positive. Okay, later on the graph can only be positive because the negative is very little. And also we know that, so the trend to the graph will be like that later. And also I have two x-intercept. Plus, I know the graph must be in between two graphs. The only way we can sketch this graph will be like that. Okay, the only way we can sketch the graph is like that. Not necessary to be accurate, but it must be that shape. Why? I have two x-intercept. I want to touch 0, I want to touch 0. How I can touch twice? It must, like a polynomial, turn somewhere to meet the other x-intercept. Also, plus, I know the graph must be in between two graphs. One positive, one negative, in between two graphs. So the only way we can sketch it is like that. And I know later on, the graph will be more positive. So it must have a positive graph, not turn this way, okay? Not turning this way. You can't turn that way. If you go that way, you will go below and cross the graph, not in between. So that's the idea for sketching addition of graph, okay? Addition of graph. It's not very hard, but you need to find the special points and know where is your graph, okay? Where is your graph? So I'm not going to spend too much time on that one. So I want you to do your homework scheme of work and plus example 3 here. Okay, example 3 here is a sine function. Got a revision on sine function, how to sketch a sine function. Remember, the domain will be the intersection. Okay, the domain will be the intersection. Okay, that's it. I'll see you tomorrow and we talk about some important thing about composite function.